Talk about decision trees. Okay, decision tree is a particular machine learning algorithm which is supervised in nature. That means it depends on the training data to train it before it can predict on some unseen samples what will be the outcome. And also it is a non-parametric supervised learning algorithm. Okay, non-parametric, we'll talk about non-parametric at a little bit lower. And it is also creating about a hierarchical tree structure consisting of root nodes, branches, internal nodes, and leaf nodes. Okay, so in computer science, we don't need to really explain students what is a root node or what is a leaf node in a tree. But I have an example to explain you later. And also, we want to tell that it can be used to navigate several courses of action to arrive on one choice, which is like one potential outcome. So let's see an example here, which is about trying to predict the risk of outcome. This is a decision tree to predict the risk of outcome. We are saying if age is less than 20, so we go to the left, and if age is between 20 to 35, there's a middle branch. This is called a branch, okay, an arrow. And then this is the right side is about if age is greater than 35. Okay, if age is greater than 35, then we go to the right side. Now you see, if when we come here, this is again we are trying to divide, checking based on the weight of the person whether they are at a high risk of heart attack or a low risk of heart attack. We are saying if the weight is less than 140 pounds, it's like 62 kilogram, so they are at a low risk. But if they are overweight or have high BMI, you can use BMI on that instead of weight. This is just an example, okay? So then they are at a high risk. So you see, this is called a decision node again. So this side we also have if the age is greater than 35 and the person is alcoholic, then they are at a high risk. Now when we can keep coming, at dividing at every stage, and then the last node are called leaf node, which have no children, as you know very well. But how deep you go in the tree, how many times you keep dividing, that is important for this tree, because if you go too deep or too much lower depth, then the tree might be overfitting. We'll discuss about it in more detail. But here I want to tell that the decision nodes help you at every stage. When you come, either you come to a decision node or you come to a final decision or outcome. Okay, so that's why we say that it can be used to navigate several courses of action to arrive on one choice. Okay, so you will be divided until you reach to a particular scenario, and that might be the classification. So for a new data, so we build this from some existing data. And now when a new person with a particular age and weight or alcoholic or non-alcoholic decision comes, then we can use this tree to find out which way they go, or which is their particular spot, or which way the low risk or high risk they are for heart attack. Now, decision tree can be used for both classification and regression. If the decision variable or the outcome is basically a continuous variable, then you say it's a regression tree. If it's a classification or a categorical variable like this low risk or high risk, then it's called a classification tree. We'll mostly look at the classification tree in this lecture. So there are four popular types of decision trees, which are ID3, which is an extension of D3 trees. We'll talk a little bit about it. C4.5, which is a successor of ID3. CART is a particular type of tree which is mostly used, which is classification and regression trees. So these are all libraries provided in the Python. And CHAID is the chi-squared automatic interaction detection trees. Now about it, there's four types of trees. We'll see that what is the generic algorithm or how to build a decision tree from the scratch given different features or parameters like this age or weight or alcoholic base. Which one will be at the root node? This is the root node. Which one will be at the root? Age or weight or alcoholic will make this decision, how the decision tree takes this decision and then goes dividing the data. You see that based on the decision which feature will be at the root, we keep dividing the data set. Okay, so we do not have any prior assumption, oh, the data set or that it will be a linear form or something like that. So that's why it's called non-parametric. Okay, and it's a hierarchical tree structure. You can see that. So it's non-parametric because it does not make any strong assumption about the probability distribution of the training data. Okay, So like the other parametric models, which are mostly the linear models, they do what they do. They always assume that incoming data or the training data is in some linear pattern, okay, like logistic regression, knife based train because they have to go through all the samples. So we'll talk about it a little more. And so this is the decision tree, and then we'll see a more detailed example.